Yes, hello friends. So this is the video tutorial for today's Leetcode problem of the day, which is medium. Maximum subarray sum with length divisible by k. So it's a pretty simple question in understanding it. You're given an array of integer nums and an integer k. Return the maximum sum of subarray of nums such that the size of the subarray is divisible by k. And if we look at the constraints, so constraints are that k and n can be as large as 2 into 10 raised to the power 5, and num size could be negative also. So the values could be from minus 10 raised to the power 9 to 10 raised to the power 9. So yeah, how can we solve this? See, if let's say we take this case 2, 1, minus 1, 3, 4, 5, and we let's say k equals to 2. If this is the case that k is equals to 2, now can we say that okay, we what are the valid sizes of the subarray that we can pick? So n here is 1, 2, 3, 4, 5, 6, 6. Right. So we can pick two elements, we can pick four elements, we can pick six elements, or I don't think that we can pick a non-empty subarray. Is it mentioned here? You are given an array, return the maximum sum of a subarray of nums. A subarray is a contiguous non-empty. Okay, so we cannot pick zero elements. So this is all the possible sizes of the subarray that we can pick, because the size of the subarray has to be divisible by k, right? So if we know this, then we can try picking two elements, we can try picking four elements, and we can try picking six elements, right? Now similarly from so this is from starting from this index. Now we have to go to the next index. From this index, try picking two elements, try picking four elements, and I don't think we can pick six elements, right? So we can do this. So brute forcing this, what would be the time complexity here? So time complexity would be, see, you go over all the indexes, right? So that is n, and then for each index you're doing a traversal of n, right, of n size. So that is n into n, that is n square. But this would again TLE, because n is of the order 10 is to the power 5, right? So this would TLE, so we cannot do this. Now the obvious answer, you would say that okay, why are we going over all the indexes? We can go over just these n by k indexes. So that is, see, what we were doing currently is that we were going over all the indexes and seeing if the size is divisible by k. If it is divisible by k, we'll add it to our answer. Otherwise, we'll not add it to our answer. So now you see that okay, because the sizes are fixed, it can be 2, 4, or 6. So we can maintain a prefix sum, and then see if we want a prefix sum of starting from I and of size j, it is of size sz. Let's say this is the size, that is would be just prefix sum I plus sz minus 1 minus ps I minus 1, right? So that is from I, you go till I plus sz minus 1, the prefix sum of this part minus the prefix sum of I minus 1, so this part, because this is the additional part. So that would give you the sum of this, basically, right? So yeah, now the time complexity would get reduced into n by k, because now we only need to go over these k, n by k points. Right. So again, still it was then n square k. Now you can say that okay, for some case this would work, for some case this wouldn't work. Right. Okay. So how to optimize this even more? But what I mean by for some case, if it is a very large scale, like of around n, then this would get reduced to n square by n. So that would come to n. But like k could be very small. K could be like 2. So that in that case, it is just n square by 2, which is what TLU. Okay. Now, how to optimize this even further is, rather than focusing on this factor, because we have optimized this factor has to be n by k. You have to go over all the n by k points, or all the n by k size. We should optimize over this. How can we optimize over this? Is, see, do we know what Kadans algorithm is? So what is Kadans algorithm? Kadans algorithm gives us the maximum subarray sum, right? This gives me the maximum subarray sum. I'm assuming we all know what a Kadans algorithm is. And if you ever encounter maximum Savarez sum, always think how can we use Kadans here. So we need to find maximum Savarez sum. Just the condition is changed, that because in Kadans we are allowed to pick any size, but here we are only allowed to pick the size which has this condition, size mod k double equals to 0, right? So how can we break this down into Kadans algorithm? If we know that size mod k has to be 0, can we combine these elements? What do I mean by combining these elements? Because see, the element, the size could be 2, 4, or 6. Let's say we combine these two elements into a new array which has just 3. Then we combine these two elements which has just 1, minus 1 plus 3, 2. And then this element gets combined to 9. Now on this we can run cadence, because see, if we just pick this element, that is we are picking size 2. If we pick these two elements, then we are picking size 4. These two elements, then we are picking size 6. Like all of these elements, then it is making size 6. So I am basically saying that for we should combine our elements, right? So we should combine these elements in a group of k. So combine elements in group of k. So basically combine these two elements, then combine these two elements, then combine these two elements. Okay. Now this combining, how can we do? Again, we will use some prefix sum. So to get the prefix sum of 0 to k minus 1, then prefix sum of k to k minus 1, right? This would be our first group. This would be a second group. So combining can be done in n by k, right? Because we only are going about these n by k. And then the size of the subarray would be what? N by k again. So n by k, and Kadans is done in n time, right? So if m elements, it can do it in m time. So we have n by k, so that is n by k. Now how many like starting positions do we need? So see here, if let's say the array was 2, 1, minus 1, 3, 4, right? This is the array, k is 2. K is 2. So this is one grouping, right? The other grouping we also need to consider is this grouping. That is, we start from this and then we start grouping it. Because see, in this grouping we are not able to pick the last element. In this grouping we are able to pick the last element. So we need to find the answer for this grouping and for this grouping. So how many groupings do we need to consider? For every starting index from 0 to k minus 1, we should consider the grouping. So that is, we have to consider k groupings basically. Okay. So that is, a time complexity gets reduced to k into n by k plus n by k. N by k plus n by k is just k into n by k, and this gets reduced to n. So hopefully this makes sense. Let's jump to the code next. Okay. So basically the answer could be in long long. So I've just initiated ll as long long. Then I create my prefix sum array. Then okay, let me make this bigger. Okay. Yeah. So I create my prefix sum array. Yeah, prefix sum of I is just the sum from 0 to I, right? I create my ons as long long min, because again we are not allowed to pick zero non we are not allowed to pick empty subarray. If we were allowed to pick empty subarray, this should be initialized as 0. Now I go over all the like k starting indexes. So all the k groupings, I create those groupings using this simple loop. So in this loop we are going from, like, j is a starting point, or rather I is a starting point. From I we go to the I plus k minus 1. This is one grouping. I get the sum, I put that sum into elements. Then I go to the next starting index. Then I basically run cadence on this elements. So this elements is of size n by k. So this would run n. Yeah, this is of n by k. So this time complexity would be n by k, right? And it's a simple cadence algorithm. Cadence algorithm, what we do is we create one answer variable. This answer is the maximum sum that we have seen, and this s is basically the sum till now. Now I add this element s plus equals to ai, the current element that we are on. If and I store that sum, is this the maximum sum in the answer? And then again, if like because we need maximum sum, right? So if we have some minus 2, 3, 4, then like this part is giving me the sum of 0, so sum of minus 2, right? So I should not pick this. I should just start my subarray from here. So that is basically my s would be now 0. Yeah, simple cadence algorithm here, and this gets submitted. I do think you can optimize this even further. Like, there could be a way that rather than using prefix sum, you can use pointers. Let me see what's the best solution. Okay, k sum, yeah, they create this k sum, k long long max by 2 prefix sum. Okay, I'm not 100% sure what this solution is, but yeah, you can optimize this, but this is fine. 50 milliseconds is very, very less. Even if we do analyze time complexity, O of n into k, this is wrong. This is not n into k, this is n. Okay, thanks for watching. Bye bye.